Hi everyone. Today is the second webinar, module number 2, where we are going to study and understand how to do a proper point-to-point or point-to-multi-point planning. Before we start, I would like to go and apologize. Yesterday you asked some questions, but we didn't went over the questions. But now I will start with your personal question, and I try to answer most of them, and then we will start immediately the course and explain how to proper doing the point-to-point and point-to-multi-point planning. I will discuss about CIR and best effort, how to do the planning, and maybe I will discuss a little bit about oversubscription and how to try to do the oversubscription when you are planning a sector or a sector of mixed best effort and CIR or only CIR customer, and I will a little bit discuss what is the main differences between CIR customer, SLA customer, and best effort customer. But Eldad is with me, and he will answer your question. From time to time, we will do a break for your question and questions. So I will try to answer those questions in real time, and the remaining we will discuss it at the end of the session or tomorrow. When we are going to introduce module number 3. So today, let's start with your questions. I put the questions on the screen so you can able to look at it. Can we use our planner to do a survey and identify potential customers? Of course. When we are doing a planning for a site, there are several surveys that need to be done. Several surveys that need to be done. The physical survey, the planning survey in budget calculator, our planner survey, and of course the RF and spectrum survey to identify sources of interference. So the answer is definitely yes. The R planner is one of the surveys which is mandatory to do before we are doing any planning. So the answer is yes. And to identify potential customers, definitely yes. Now remember that we have the set service evaluation tool is part of the survey that you can do before going to deploy any customer, and of course you can identify if you did the deployment and the installation of a sector. You can identify potential customer that can be assigned to this specific sector, and you can predict the performance that this customer can have in case you are going to deploy and to add additional customer to existing sector. So yesterday somebody asked me about the service evaluation tool and how we can reach the service evaluation tool from the R planner. Immediately after the session, I will show you the service evaluation tool, and yes, it is part of the survey that you can do when you are doing a planning. What are the parameters that LBC we need to enter? What must be done in calculate point-to-point or point-to-multiple? A very good question, and actually today I will start with with the link budget calculator. Let me show you again. And remember that the link budget calculator provide us the bottom line, the throughput, and the performance that you need to achieve. But again, there must be a policy for each company or each carrier. What are the benchmarks that need to be achieved in order to protect our investment, to protect our performance, and to guarantee the performance. Yesterday, I discussed about trade margin. So my policy, if you are conservative, and I'm personally conservative, I prefer that my trade margin, when I design a link, to guarantee the signal, level in case of deterioration in sensitivity, and to ensure the service is between 10 and 20 dB. If you look at the screen, the default is 6 dB fade margin, but I don't think it is sufficient. I put usually above 10. If it is above lakes and water, I need the fade margin to be 20 in order to ensure the same quality of service and sensitivity in case of reduction in the air condition. So fade margin is the first parameter that we need to take into consideration, how to ensure the efficient, the gain, the signal in case of deterioration. So we can continue to keep the sensitivity and the modulation to guarantee the service. The second is availability, and yesterday we discussed about availability, how to predict the probability of outage. So it depends on fade, multi-passes fade, distance, of course, and equipment failure. So availability usually is 999 or 4 nines. When I say 9, it's percentage 99.99 or 99.99. In many cases, you can find availability demand of 99.95, which is good to guarantee the performance in case of outage and the probability of failure. The next parameter is the RSS. RSS, if you look at the RSS, you can see the expected RSS in case of distance. So, and today we will start to do the planning and the link budget calculator. I usually ask for the installer to provide me RSS between -45 and -65. But if you get -70 and the link works and there is a long distance, you can still live with this. But to be efficient and to guarantee the performance, I say between -45 and -65. This is the ranges of the RSS level that I want to achieve in a proper installation. But if the installer come and tell me that in 1 kilometer you get -70, I will say this is impossible, and the installer can continue and need to continue to be in the site and to do the alignment, the proper alignment. The WinTouch application, the cellular application, actually doing this for the installer and provide the prediction of the RSS level according to the real performance. So If the installer go to the site, take the WIN touch with him, most probably you need to get the same RSS level as the R planner recommend. So if we get 1 dB, 2 dB, 3 dB more than the R planner, I can accept. But if it is 10 dB more than RADWIN planning recommending, I say no, there is something wrong, and continue to insist to get better RSS level. The distance is something that it's a condition that you need to answer it with a proper antenna gain, with a proper TX power, and of course, you need to calculate which antenna gain you need to provide according to the link budget calculator and the modulation that you want to achieve. So, and of course, you need to take into consideration the climate and the C factor into calculation to maintain the link and to maintain your performance. So this is the major parameter: fade margin between 10 and 20, availability 999 or 49, RSS between -45 -65. TX power is a outcome of the transmitter. If there is regulation like ETSI, you are limited to ERP of 30 dBm, 1 watt or 4 watt, it depends on the country and the regulation. The modulation is, the idea is to achieve the higher modulation. Higher modulation guarantee higher throughput. But again, the modulation is based on sensitivity and sensitivity level and carrier to noise, parameters. So the wish is to get the higher modulation and to guarantee better throughput. But if the air condition are interfered, the air interface is interfered and there is noises, we can expect deterioration, and sometimes it's better to go to lower channel bandwidth and to guarantee to have higher modulation. It's always a trade-off of channel bandwidth and modulation, which is more ensure a better throughput. It's a trade-off between dynamic channel bandwidth and the modulation. Of course, the bottom line is the throughput, the aggregated throughput, according to what you invest in the link. Proper investment, proper planning, save cost and save money, and of course can guarantee a better performance to your customer at the end. And this is the idea. So I went over the LBC parameters. This is the question that was asked. The R planner is free, but you need to be well certified and understand RADWIN technology and RADWIN ideas and RADWIN policy in order to understand how to plan. If you are Cambium or Ubiquiti customer and you try to work with the ideology and the logic of RADWIN, it's different logic. We have a very nice performance with beamforming antenna in the point to multipoint. We have a very good set of interference mitigation that none of our customers have. So in matter of radio, I'm confident that RADWIN provide a very nice package of performance to our customer. That is why it is free, but you need to be certified. I have a question here that treats why the R planner is online. It's online, but I must tell you that it is online. The server is in Tel Aviv, but all our customers are protected. The server is secured. We are working with military all over the world, and of course everything is confident, and any information is not going anywhere. It's kept in the server in Tel Aviv. But we are keep thinking how to provide offline access to the R planner. It's there, it's on the table, and the next generation of the R planner is taking into consideration also some security aspects. And I believe that in the next generation of the R planner, it will be offline, and you will not distribute it to any customer. But keep in mind that the information is confident to all our customers. Everyone has its own credential, and no one can get the information unless you are sharing this information. So I'm personally not familiar what any customer did in Europe or in Africa, unless they are coming to us and asking for advice how to change the plan or add plan and so on. So, but remember that we are coming with a new generation of our planner. It's coming soon. It's based on something, the same technology, the same idea, and it's coming soon. So, can I get the certification from RADWIN for radio planning? Of course. Anyone that need a certification, I may consider to do a global generic course for customers. And I will provide the certification for the radio planning. If you need it for any planning, or you have a project that you are going to conduct, it will help me to help you to provide you a certification. Somebody asked how long the time section is going to be. Actually, I can start now and never end. I have a lot of information to provide to you, and apologize. Yesterday we a little bit. I took more than the 1 hour, and probably today it will take more than 1 hour. Today is very sensitive and very important to go over the planning, the point-to-point and point-to-multipoint, and to understand the difference between them, the different requirements, the different aspects of point-to-point, point-to-multipoint, to look at the synchronization, and apologize if it takes more time than usual. Is it possible to have, after the presentation, the recording and the slides? I believe so. And please, everyone that needs the presentation, please send me an email, and I will take care of you personally, as I always do. Is it possible to get our planner to the end user? It's a good question. Usually we provide the R planner to our partner who are definitely certified to have the R planner access. But you know, if you pay me a little bit, I give you more. So this is the relationship here. So just send me an email and I will try to do my best that you have the R planner, the radio planner, because I believe it's very important for you to get familiar with our technology or our philosophy. At the end, RADWIN come with this philosophy. Our product have philosophy, and this is the idea. We are not very cheap in the market, but we are very sophisticated in the market. And we want to keep this quality. We want to keep the quality. We want to be with the good quality to provide a good performance to our customer. And at the end, always I say that any commercial is negotiable. So you can get a good package of performance, and you can get a good package of commercial. This is coming together, and at the end, you will get the support from our team, the professional services, and our support guys all over the world. And okay, this is the part of the question. I will drop the question and let me start with the course. And today we are going to deal with how to properly configure point-to-point and point-to-multipoint. And remember, let's start from point-to-multi. Creating a point-to-multipoint link, creating point-to-multipoint link using AutoConnect, and creating point-to-point link. Before I will start, like I did yesterday, we will start from the link budget calculator. I will raise the link budget calculator and I put it in front of you. Remember, all the benchmarks that I gave you need to be in front of you, need to be considered and well considered. On the left, you can see the RADWIN 2000. On the right, you have the 5000. Now, I go from top to down, and remember, when we are doing the link budget calculator, is per sector and per subscriber unit. You need to do it's like a survey or testing that you are doing for each one of your customers. At the end, the bottom line of this link budget calculator, it gives you what is the quality of 1% resources that are going to be allocated to our customer. Now, at the end, the resources that we allocated to our customer on the point-to-point link, they will impact, of course, the aggregate throughput and the latency that we are going to expect, the delay, the average delay. The more I have resources, the less I have delay. This is very simple. And in page, I put a slide in this presentation. Let me find it. Here. Let me extend this presentation. Important. Not considering CIR resources allocation. The following slide explains the process of assigning CIR resources to achieve the requested service. Service is to put your rights is based on the total aggregated of the sector, but at the same time, please refer to RADWIN point-to-multipoint presentation for detailed information of dynamic bandwidth allocation and CIR allocation in particular, and CIR vs best effort air interface. But look, the typical latency, if I put 5%, I will get 11 milliseconds. If I increase the resources 15%, I will get 6.5 millisecond latency. 50%, 6 millisecond latency. Best effort, one-way typical latency is 43 millisecond single SU, 3 millisecond one-way latency. Now, it's very important. Now, in most cases, and remember, we are here to make money. We want that first to provide a good performance to our customers, but on the other hand, we all gathered here to make money, and good money, and to protect our business. So latency is part of the performance that we provide to customers, especially gamers, or real-time traffic like CCTV, video. And we want to guarantee this performance. But in many cases, in majority of the cases, we will do oversubscription. We will reduce the CIR that we provide to our customers, but because we can. What makes the algorithm very sophisticated to provide more resources to our customer, and I will discuss it. There are a few methods how to do it, how to implement oversubscription in RADWIN networking and not in a RADWIN solution. And I will discuss it later when we are getting there. But first, let's go back to the link budget calculator, and let's do a little exercise, and then we will go to the outline and start to do this actually the same, but with a more proper way to do the planning. So I will put the 5,000 point or multi-point. I'm choosing a 50 megabit per second subscriber unit. Let's choose the connectorized product. I'm choosing the 5.4 universal, or let's say a frequency, connectorized. I'm working in 40 megahertz. I'm using 20 dBi antenna gain on the HBS side and 28 on the subscriber side. I want to work with adaptive. The fade margin, I will put 10 dB as the default and the minimum fade margin that I want to achieve in case of deterioration of the signal and the gain to guarantee the performance. This is the margin that I want to achieve. Now, when I unchecked the adaptive, you can see that the red comment became red. It means that there is an error. The error means that the fade margin is less than the 10 dB, which I put as the default fade margin, the threshold for the fade margin. Now, you can see that, let's look, put 10 kilometers. I want to take 50 megabit per second subscriber unit up to 10 kilometers. The antenna gain of the subscriber is 28 dBi. Now I start to reduce the modulation, and I get minus 60 RSS, 14 dBm fade margin in 10 kilometers. The availability is 4.9, and the throughput that I can get in 10 kilometers is 51 megabit per second aggregated throughput. Let's take into consideration the climate factor. Let's say that we are working in moderate areas. You can see that immediately the availability dropped to 99.98. It's not enough. I want 4.9. So what I can do? I need to drop a little bit the modulation. Now, I get availability of 4.9. The fade margin is 21 dB. The RSS is minus 57. But I still get the 51.7 megabit per second in 10 kilometers. But look what happened. How many resources I need to allocate in order to achieve the 51 megabit per second? Remember, the more I have modulation, and remember that we are working in MIMO 2x2, MIMO 2x2, the more I increase the modulation, look what happened. The availability dropped to 999 and not 49, and we get more resources on 1%. Now the 1% is equal to 1.5 megabit per second. If I drop the modulation, the availability becomes 99.9949, and 1% is equal to 1 megabit per second. At the end, every percent is important because this is the resources that you are going to provide to your customer in case it is SLA customer. So now, if I open the question mark, and remember yesterday I showed you that there is a magic. I open the question mark and I get a table that explains what is 1%. 1% is aggregated actually 1 megabit per second. If I want to achieve all the 51 megabit per second, I need to allocate 80% of my sector. And you can ask me how many subscribers you want to achieve in this sector. And actually, it's one and nothing. One subscriber take all my resource. And you can understand this is impossible. It's impossible. It's like a point to point. At the end, we are losing resources, we are losing money because we need to invest more the sector on that area. When one subscriber is eating most of the resources that we have. And then how you can discuss about oversubscription, and it's impossible. It's totally impossible. Now look what happened if I increase the modulation. Let's take it. Let's say that our sector is average 4 kilometers. Let's take the average distance in 10 kilometers, not in 6 kilometers. Let's take it in 4 kilometer radius. Look what happened. I have 100% availability because you can imagine I'm using 28 dBi antenna in 4 kilometers, which is overkilling. But it's okay. Let's continue with this. The RSS is minus 49, which is good. The fade margin is much more than expected. But look, I opened the question mark. 1%. Now let's increase the modulation. Let's put it in the maximum modulation. Let's put 9 the phase margin. And what happened? 1% is equal to 2.6 megabit per second. In order to achieve the 51 megabit per second, I need to allocate 20% of the sector and not 80% of the sector. If I want to guarantee 25 megabit per second aggregate, I need to allocate only 10% of the sector. And look at the latency. The latency is 40 milliseconds when I allocate 1%, which is very similar to the best effort customer. And if I allocate 20%, look, the delay, the latency is 6.3 milliseconds, exactly like we described in the slide here. Single SU is 3 milliseconds one way, 6 milliseconds two way. Very similar to the latency that we get. Later on, we will discuss how oversubscription can be well calculated not to interrupt the service and not interrupt the latency and the performance of real-time traffic, although we want to achieve oversubscription, and it is important to implement and deploy oversubscription because we want to get more money at the end, and this is important. So this was a very nice trial to understand, one, how distance impacts the resources that we are going to allocate, and how we can improve the resources by increasing our investment. Look, in 28 dBi, I get this resources. 1% is 2.6 megabits per second. Now let's look if I decrease the antenna gain of the subscriber to 22. Of course, the fade margin is decreased, the RSS is decreased, and without relation to the fade margin, 1% now is 2.6. But if I reduce the modulation, let's increase it one more, I can see that that 1% is 1.5 megabits per second. In order to achieve 51, I need to double the resources that I need to allocate for in order to achieve the 51.7 megabits per second. Now again, for each kind of subscriber, you need to do some kind of simulation to understand what is the antenna gain that you want to achieve, what is the modulation that you want to get. But in 4 kilometers, I usually use the 22 dBi antenna without fixed power limitation, and it's good. Actually, I can increase more the modulation. I get 9 dB fade margin and minus 60 dBm RSS in 4 kilometers. 1% is equal to 2 megabits per second. In order to achieve the 51 megabits per second, I need to spend 30% of my sector resources. I hope this is clear. Let's continue with the R planner, because the R planner is doing it for you. Remember all the benchmarks that I did: the fade margin, the availability, the RSS, the fixed power, the modulation, the distance, the climate factor, the antenna gain. All these are going to be calculated in the planning that we are going to do with the point-to-point. Okay, right-click where the site needs to be installed, navigate through the new menu and shown below, click site and add a site. Check SU on site, default project SU, other parameters are shown, can be adjusted. So let's do it together. What I'm going to do now is show you how to do proper point-to-multipoint link. This is a prepared point-to-point solution. Actually, it is CCTV in Nigeria. It's a safe and smart city where you can see here 2 sectors covering 90 degrees with a jet beam forming. There is a point-to-point connected between them for aggregation layer. Here there is an additional point-to-point link for aggregation. So actually, in every point-to-point link, point-to-multipoint link, there is a camera and the smart node at the edge of each point. Actually, it's a street We are covering the streets with cameras and other sensors, civilian and military sensors. And this is an example of a combination of point-to-point and point-to-multi. Let's do something. I'm doing right-click. I add entity. I read site, and I call it a test site. Now, yesterday we discussed how to add site. I can add site by CSV file, by manually coordinates. I can import site, I can import link, I can import HBS. I can import site with a KMZ file or CSV file or KML file. But here I did it manually. I did right click, I added entity, and I add a site. Now, if I go to the site and I will do right click, I have properties. Any site can be a subscriber unit or not. If I right click, I can add base station. Let's look at it again. This is the site. Let's take the site close to the plan. Let's put it somewhere like here. Now, if I do the properties on the site, remember I can turn it to be a subscriber unit. I can define the frequency. I can define the subscriber unit according to the catalog that we did yesterday. And immediately I have a site. It's a subscriber site. Remember, this is a point-to-point site. This is a point-to-multi-point site. Now, let's take this site. Let's take it here, for example. Now, remember, I have a point-to-point link. I will delete the point-to-point link. And now we have again point-to-point link, point-to-multi-point link, and a new site that I'm going to convert it to a point-to-multi-point. Now we have here a 3 sites. When I have a 3 sites, I immediately think about point-to-multi-point base station. Let's say that we have a tower here. I will add an entity. I will call it HBS tower. I will go right click, add HBS. I will call it HBS southwest. I determine the frequency. I determine which base station. It can be Jet Pro or Jet Air. Let's say that I put the Jet Pro. Jet Pro is CIR, Jet Air is best effort. When I choose best effort, I can ignore the CIR. But when I choose Pro base station, I need to allocate resources. How many resources? Link budget calculator like we did before. But let's continue. I'm trying to add a base station. Let's say the channel bandwidth is 40. The frequency is 5.475. I need to define the sector ID. I'm choosing the right platform for subscriber unit according to the catalog that we did yesterday. Remember that the Jet has an integrated GPS. So we have the integrated GPS. Now, let's look at the lower part of the planning. And I will repeat it again. Transmission ratio. Transmission ratio is the ratio between uplink and downlink throughput at the end, yes? But actually, this is the TX power on the uplink and the TX ratio, the clock TX ratio. At the end, when you change the clock on the uplink and downlink, you're changing the duty cycle. The duty cycle change the uplink downlink throughput accordingly. So we can play with the ratio. I take it to the right, to the left, I have more uplink. I take it to the right, I have more downlink. I take it to the right, to the middle, we have 50% uplink downlink. Now, so this is how we can control the uplink downlink ratio in a base station. And remember, and I tell it to all my customer, when you are discussing about uplink or downlink, it's relatively always to the subscriber unit. Uplink is from the base from the subscriber, downlink is to the subscriber, always. You need to take into consideration that the subscriber determines the uplink or downlink, not the base station. Although the ratio is done on the base station, because the base station is the parent for all the solutions. Every change that you are doing on the base station will impact all the subscribers, and it can be up to 64 subscribers per sector, or per beamforming, depend on the Jet dual carrier. So this is an idea you need to consider it, that the ratio of the transmitting impact the ratio of uplink downlink when the subscriber is the reference. Now, remember that we can adjust also the CIR or the best effort resources. We can do 100% CIR. We can have, like recommended, 2080. CIR best effort, or we can do only best effort sector. Now, again, when you decide that it is the best effort sector, Jet Pro can provide and support both Air customer and Pro customer and CIR customer. Jet Air support only best effort customer. You cannot mix. And remember, the Pro can mix between Air and CIR customer, and you need to define the ratio accordingly, according to the resources that you are willing to spend, and according to the statistical subscription number that you are familiar with your own network. Otherwise, you can experience a bottleneck of throughput. And we will discuss it. What are the methods to do oversubscription? There are two methods. But meanwhile, now we need to define the ratio between CIR and best effort customer. The recommended ratio is 2080, 20 CIR, 80%, 20% best effort. At the bottom you can see also the resources that have been allocated accordingly. Currently, we didn't allocate any resources, and we have 100% free of resources. Now we need to go upstairs. The antenna of the jet is 20 dBi integrated. The subscriber unit is 25 megabit per second embedded antenna. We can also put the turbo gain, or we can put 28 dBi antenna or 32 dBi antenna. It depends on the distance. But currently, because of short distance, I will go with the turbo gain, and I can determine the azimuth regard towards those subscribers. Something like this. I will put the coverage. Let's say that it is 3 kilometers. I like the red color, so I put red color of coverage, and I do the coverage. Remember, the holes, the dark areas are non-line of sight areas. The more you are going far from the distance from the base station, the different color show you the values of the modulation. So the more you are getting far away from the base station, the modulation drops, and the dark areas are non-line of sight or near line of sight condition. Let's go back to the base station. I'm doing right-click, HBS, least current, HBS, and I have the base station. Well, let me put a height higher than, let's say that average height on the tower is 35 meters. And you see that immediately the coverage is calculating again. Now I have a better coverage, less non-line of sight, and now I can connect a subscriber to the base station. Now, right click, and I create a point-to-multipoint link. Next, and I have a point-to-multipoint link. I can see that the distance is 1.1 kilometer. I can use or not use the turbo gain. And the profile, let's look at the profile. I have a little bit, I need to get higher. And now I have a better clearness, 1.0, which is good. But I still have no resources. And remember, in 1.41 kilometers, I want to achieve throughput. Currently, the typical latency is 43.1 milliseconds. This is the average throughput for best effort customer. Remember, best effort customer had 43 millisecond delay because it's provided by default. The sector is reserved 1% for each best effort customer. And now, if I want to achieve, let's say, 50 milliseconds, 50 megabit per second, I need to allocate 30% of my resource. But remember that we are working 40 mega channel bandwidth. Let's put now 20% on the downlink and 20% on the uplink. Let's look what happened. We achieved 21.57 and 22 uplink downlink. So if I put here 25 and 25, probably I will get 50 megabit per second aggregated, uplink and downlink. But you cannot achieve more than 50. This is symmetric. I have 26 on the uplink, on the downlink, and 27 on the uplink. The delay becomes 6.9 milliseconds, which is very similar to the planning that I did on the web. 6.3 millisecond delay. And this is what I expect the real life, unless you are losing resources. And you can lose resources because you didn't plan well the sector. Now, so we have a 1.5 kilometer point-to-multipoint link. The subscriber can be 25 Mbps or alpha 50 Mbps. Let's leave the alpha. Alpha can work like a subscriber unit, which is very good. So we can achieve 50 megabit per second when we allocate 25% on the uplink and 25% on the downlink when we are working in 40 megahertz. Let's look at the benchmarks. The ERP is 44 dBm, the RSS is -50, the fade margin 9.2, the modulation are 256 QAM on each side of the link. Perfect. Now, if I want to reduce the number of resources, I can delete the link and change the channel bandwidth from 40 to 80, and look what happened. And I get more capacity when I have less percentage, less resources, but I have much more throughput. Look, if I put all the 20 like I did before, I can get almost 50 on the uplink and 50 on the downlink to guarantee the performance definitely. Now, let's look at it. What happened if I change the ratio on the base station? Remember, there is a CAR best effort ratio. If I put 100% and I go back to the link, I type on the link, I do properties, and look what happened. The latency became lower. I have 20. I can reduce the 20 to 15. Let's see what happened. Let's put 19. 19. I get all the 50 megabit per second on the uplink downlink, the latency reduced, and I have much more resources to allocate to other customers. More resources, I can guarantee a better performance to other subscribers. Now, this is the limit. Let's put 17 and 17, and we are perfect. Almost. Now, remember that in RADWIN dynamic allocation of bandwidth, there is a burst. We can allocate SLA, CIR to customer. We can limit the traffic by the maximum information rate. but every customer is that if there is no meal, no maximum information rate, can get more throughput because of the dynamic allocation. It can get the maximum throughput if there are resources which are not allocated or resources that are not being used. This is the way we can guarantee a better performance and to guarantee a better throughput and latency to our customer. And this will make me to decide to discuss about oversubscription. There are two methods for oversubscription. One is to provide less CIR to customers and to count on the bursts, the free resources that exist to guarantee the traffic. So one method of oversubscription is to provide the less CIR resources, but to utilize all the resources of the sector. The second method is to allocate resources, let's say 70% of the resources of the CIR or 80% of the CIR, and leave 20% of resources free. So everyone that need resources when it's run the traffic, he will take those free resources. And this is the way we can guarantee one, oversubscription, 1 to 2 or 1 to 3, and to guarantee the performance for each one of these subscribers. This is the calculation that we are doing. And this is the two methods that exist to do oversubscription. So currently, this is the link in 1.1 kilometer. I have a turbo gain. Let's see if I reduce the turbo gain to embedded antenna, 16 dBi antenna, you can see immediately that the resources are dropped and the capacity is dropped. The 17% is not enough. Look, I go back to 22 dBi. You see, I get the 50. I drop down to 80 to 16 dBi antenna. Up, I get much less resources, much less throughput. And you can see the RSS dropped to minus 53, which is good. The Fed margin dropped to 7.4, which is acceptable. It depends on the policy of the company. And I'm not sure that we can accept it, but look what happened if I go back to 22 dBi, 70% guarantee, 50 megabit per second on the uplink and 50 megabit per second on the uplink, on the downlink. The RSS reduced to minus 49, ARP is 45, and the Fed margin is 6.2 dB. The availability is 99.9996, which is excellent. And the latency is 6.9 milliseconds, which is good. Probably in 1.1 kilometer, I will lose the embedded antenna anyway, because I don't want to invest turbo gain or external antenna on 1.1 kilometer. This is the logic, but again, you need to decide and to invest the link. Now, in case where there are many subscribers in a point to multi-point link, we can do auto connect. Let's do the auto connect. What I'm going to do now is to color all the area and then press on the auto connect. Look what happened. Now there is a magic, and this magic can contribute to do the planning for thousands of subscribers and thousands of base stations. Of course, it will take more time, it depends on the quantity, but this is the idea. I can do auto connect. If there is more base station, let's add one more base station to make it more complicated. I will add the entity site. I will call it HBS2. I will add HBS2. Again, I will doing the same. I put sector ID. And what I'm going to do now is to point the azimuth towards the same, let's say, the same sector. Now, what do you think? What algorithm will decide to choose? Base station 1 or base station 2? This is a good question, and I'm asking you, what do you think? Before I will start, you can write down the answer, and let's do it together. Now I'm pointing the two sectors. I'm pressing the auto connect algorithm and let the machine work for me. I don't need to go one by one, right click, double click, and put the line between base station and subscriber. I'm letting the machine work for me. In majority of the scenarios, I will determine and you will determine the base station location. It's easy because there are topological areas where it's a high tower, or there is a transmission there close to the transmission area. So the base station will be obvious. And the subscriber, it depends on your customer distribution in the area where you are asking to provide the service. So what I did, I colored the area. I mentioned which subscribers are subscribers and which is the base. And now I'm letting the algorithm to work and connect the subscriber to the preferred base station. And let's see what the machine decided to choose, base station 1 or base station 2, because both base stations are pointing the same area. I put finish. Boom. Now I will ask you why the algorithm decided what decided. The answer is clear. Look, from base station 1, from base station 2, this is base station 2, the two subscribers are located on the dark areas. And on the edge of the coverage. So I believe that if I would delete HBS1, there was no alternative. But since there are two base stations, it prefers to choose base station 1 and not base station 2. Let's do this exercise. I will delete base station 1. And I will repeat this exercise. Now remember, this is the algorithm working for us. And why not? Let it work for us. We save time, we save our time, and let the machine think and do the decision for us. And this is very a nice exercise. Now I will do the same. Just a second, let's do the same. sorry, my fault. I need to decide that this is a subscriber unit. And remember, like I did before, I choose the subscriber. Alpha can be a subscriber, so I'm good. And now I can do the auto connect again. What I'm doing for 2 subscribers, I can do for 1,000 of subscribers. Now I operate the auto connect algorithm and I'm continue. I do the next and next. Now there is no other choice. The one base station, 2 subscribers, and let's see what happens. I can guess that there will be a link, but there are obstacles. Look at the one not connected. If I can point the details, we have a stop, and let's start again. Okay. We have the same base station. I'm trying to do again the auto connect. Next, next. And finish. One link could not make it. Why? Because of topological obstacle. Look, if I do the link manually, I can face the same problem which the algorithm is facing. It's a profile. So this is why the algorithm preferred to choose sector 1 and not sector 2. And this was the auto connect algorithm. Now, every time you have a red alarm, it means that there is a fault somewhere. It can be synchronization, it can be topological area, it can be the resources are not sufficient. In this case, we need to increase the resources. I put 10% and 10%, and I'm increasing the resources. And you can see the red alarm is disappeared. Still, the millisecond delay is not enough. You can see that we can face a little bit more delay than usual. I can increase the antenna turbo gain, and still I need to deal with the profile. The profile is a little problematic. I will try to increase it to, I don't know, 20 meters above ground. And I have still an obstacle here. So if I'm not taking it to a higher distance, I cannot cope with this. That is why the algorithm decided to choose base station 2 and not base station 1 that were pointing in this area. So this is what the how to connect and how to allocate resources to a base station. If I go to the base station again, I look at the base station, I drop down, I scroll down. Remember the two clocks that we have at the bottom. How we allocated the resources to each one of the subscribers. 2% to factory, 10% to test, and 88% are free resources. If I go to the original plan, I can see what happened with the original plan, what I did. If you can see, right click, base station, list current, HBS, you can see that this is the resources that I allocated on the uplink downlink for each one of the resources. You can see that the downlink is bigger than the uplink, and we have more resources on the downlink than on the uplink. Yeah. And again, we have the 20-80% uplink downlink. Okay.
Hi, Shimon. I want to just intrude for a minute.
Okay.
Shimon. Hi, a lot of people are asking, and I want to just say to everybody, to get an R-Planner account and access to the R-Planner, you need to go to undergo a training, a course, a RADWIN training. Okay, only then you will get a R-Planner account and access. Okay, in order to do this training, you need to contact RADWIN or the partner or the agency that actually buys the RADWIN product, and they will purchase a training and set it up. Okay? Thank you. Shimon, that's it.
Okay, good. So this is how we did the planning for point to point, point to multi-point. We looked at the CIR, how to allocate the CIR and the resources according to the link budget calculator, the throughput that you expected. Now, when we discuss point to point, it becomes much easier. When you need to connect two sides to one link. And the design of the link is much easier. In this case, we have a link. If I do properties on the link, you can see that I have 2 D+, 2000 D+, 750 Mbps in distance of 10 kilometers. 10 kilometers. In distance of 10 kilometers. Because of the distance, I use the 28 dBi antenna gain and 80 megahertz channel bandwidth. Remember, this is the aggregated. Some aggregating link you can see deep on the plan. I did in this area because this is the control room where all the cameras are aggregated. So we did a concentration area, a concentration area where I want to achieve more than 600 megabits per second or almost similar to 500 megabit per second in 3.1 kilometers. So we use the D plus integrated antenna, 80 megahertz channel bandwidth, and the frequency is 5520. And again, I did another consultation and another aggregating link between the control and the other base station here. So in order to create a point-to-point link, let's delete this link, and again, let's design it again. Click, control and click. And I create a point-to-point link. Next, it's a D plus embedded, it's a D plus external, D plus external, and antenna is 28 dBi. Channel bandwidth is 80. I still have a profile problem, so I will put it, let's say, in 30. Not enough. Put it in 60. And we have some kind of link in 60 meters on one side. So actually we got in 80 channel bandwidth of 80 megahertz, 400 megabit per second, 460 megabit per second throughput, aggregated throughput in this link. Now, let's look at it. Now, the next step, this is the link. This is the property. You can see that the delay is 3 milliseconds. The aggregated throughput is more than 460 megabit per second when we are working in 80 megahertz. So we have a point-to-point link with a D plus, according to the catalog that we did last time. Now we need to look at the synchronization. Synchronization is very important. I'm going to the radio parameters layer, and I enable the hub side sync. Now, yesterday I talked that in every tower there must be one audio, which is the master. If there is a GPS or the GSU is the master. If there is a base station and there is an integrated GPS, then we need to enable the integrated GPS. When I did the plan for this plan, we need to take into consideration that GSU is not avoidable. You need to take care that sometimes you cannot ignore GSU. External device, GPS device that you need to add to the system in order to synchronize a mix of point-to-point and point-to-multipoint. So if I'm going here and I go drill down, you can see that there is a HSC, which is the client, independent, which is independent unit, and there's no master. Why there's no master? Because the GSU is the master. So every junction, when there is a point-to-point and point-to-multipoint in a very small area, I need to consider a GPS, a GSU unit to synchronize the plan. Let's look at the ruler. You can see that the distance between two base stations is almost 6 kilometers. Now, Because I have 6 kilometers, I need to take care not only on inter-site synchronization, I need to take care of the inter-site synchronization. So every junction, when there is a point-to-point, point-to-multipoint, I put GPS, GSU. If I go back to the project setting, you can see that I decided to do a GSU synchronization. From the very start, I decided that my plan will be synchronized with the GSU. So how many GSU do you think I need here? I put a GSU here, a GSU here, a GSU here. Now let's look. If I do properties on the junction, you can see that I have a GSS property, and you can see that it shifted. The phase is shifted. If I go to the upper junction, I do property, and you see that the GSS is normal. If I go to this junction, normal. So I have a GSU here, GSU here, GSU here. This is normal, shifted, normal. If I adjust, excuse me, if I adjust the shifted to normal, and this will be also adjust to shifted, or let's do like this. I'm going to base station 1, and I will remove the GPS. And let's remove it from here. And let's remove it. Remove it. Oh. Let's do something like this. Okay. So currently there's no synchronization anywhere. Let me just delete this link, and let's reestablish the link. This is a good example. Now, you can see that we created a link, and oh, 2 links became red. Now, this is because of synchronization. Now let's do again. I will delete point-to-point link, and you see this become green again. This is the idea of synchronization. How synchronization can impact the performance if you are not doing it properly. Let's do it again. I will create a link again here. And I created the link. Let's put it the D plus, external, with 28 dBi antenna.
Sure. Can you also show the interference between the links, the details?
Yeah, this is
Somebody asked how you can see the mutual interference between each links.
now, yeah. Now when I go back, this is a good idea. Just a second, it was good. I want to reach a situation where it is. Create a link. Okay, this is a good example. Now, if I go back, you can see the interference between the two links. If I put the details, it will give me the information which is the interrupted according to RSS levels, which is the most interrupted link that caused to the problem. And since I see the fade margin drop immediately and there is interference, I can immediately think about synchronization. And if the synchronization, I see that this is a client, this is a client, and all the rest are independent. But still, this is the client, and here it is independent. I can imagine that this is interfering the other link. So if I go to the property, I want to know which is interfering. I look at the details, and you can see which is the major interference. The 47 is definitely interfering the other subscriber, the other point-to-point. So this is the idea of synchronization. I need to add the synchronization to each base station. It can be the internal GPS, serial synchronization, or GSC. Since we have too many sites, I will add the synchronization. Here, I will add the synchronization here, and I will add the synchronization here. You see, all the links become green except this one. And let's look at this one again. I see that this still there is a lack of synchronization, so probably properties, we will do it shift. And here, normal, shift, normal.
Shimon, we need to wrap this up.
Good. So synchronization is very important. Again, intersynchronization is very important. Sometimes it's important to do a physical separation between the point-to-point and point-to-multipoint in order to avoid self-interference. So this was a good example how we add aggregation link between point-to-multipoint solution, and the synchronization is interfering. And you can see a red alarm and red arrow that indicate that we have lack of synchronization. And just you need to enable the button of IHSS and give you all the information about self-interference or collocated channels that are interfering or intra synchronization. So this is was a explanation about point-to-point and point-to-multipoint. Let's open the slide again and let's look whether I can add or add some information which is not clear. And if you have a question, Eldad on the other line may answer. And Eldad, if there is something that we need to repeat again, please let me know, and I will repeat it again so the audience can get the information again. So please, if you have any important issues, please interrupt me and I will repeat. And
no, something special.
So I will go again over the slide and let's see if we missed something. Adding a new subscriber site. Remember, I did a right click, I put an identity on the map. I decided on the checkbox if it is a subscriber unit or it is a base station. Right click where the site needs to be installed, navigate the new menu, click on site and add site. Remember, the site can be a subscriber unit and we need to just enable the checkbox to enable the MCU subscriber unit. And we drill down, we can determine the frequency, we determine the equipment and the antenna that we prefer to use according to distance and according to LBC, of course. And adding the new SU radio site, SU name, site coordinates, SU throughput, CIR best effort, and frequency. Adding a base station, sector site, select the best location for installing the HBS sector. Remember that HBS need to cover more than one subscriber. It's 64 up to 64 subscriber. In the jet dual carrier is up to 128 subscribers. So the topological near line of sight, non-line of sight is very important. And when you are doing the auto-connect, remember that the auto-connect check this topology, and if it's not find the way to put a link, it will drop the connection. Adding HBS, use the mouse right click to manually adding the site. Next, right click to the HBS site, select add and to add an HBS sector. If there is no HBS radar selected in your product library, the catalog, this option will not show up on your menu. Then we define the base station, the frequency, the name. Usually the name need to add the direction, south, west, east, or any number that indicate the direction of the coverage. We need to allocate the frequency, the TX power, the antenna. And the antenna is usually, if it is a base station and it is a jet, then the antenna is integrated 20 dBi. If there is the integrated GPS, then we are using the GPS integrated. If it is a mix of point-to-point, point-to-multipoint base station, then we need to add GSU, external GSU, in order to synchronize like we did with the former plan. Then we have the azimuth button where we can describe exactly the azimuth and the degrees of the coverage. And does your sector carry symmetric or asymmetric traffic? We need uplink or downlink. Depend on the traffic that we need to allocate to the subscribers, more uplink or more downlink. If it is CCTV, we need more uplink. If it is other, we can put the symmetric traffic. And then you can see the two pies where you allocated the CIR and what is the utility of the sector on the uplink and the downlink. If we are using only best effort customer, which are equal share, then we have a button to use only the best effort customer. We put the azimuth, the coverage, color the coverage, and it's important. When you are coloring and give the colors have a meaning. It can be frequency, it can be a sector, a special sector, or so it depends. If we are using reuse, and RADWIN can do the reuse too, the colors are meaningful. So use the colors, use the names to identify your coverage area and the radius of the coverage. Remember that dark areas are non-line of sight, and the color itself changes according to modulation. Again, gray is end loss, red is line of sight. Now, once we did the base station and we configured the base station, pointed the azimuth, we can connect and create a point-to-point link. The link needs to be green without any error. If it is red, it means that there is a problem. Lack of resources, lack of paid margin, lack of synchronization, lack of profile. Something is wrong with the link, and we need to understand what is why it is not functioning, and we need to correct this error. Again, we need to allocate resources. And this is important. And remember that the resources are important to design your sector and design your network. It depends on the subscription number that you want to achieve. But remember, if you are doing incorrect planning, it will impact the service at the end for all the subscribers. and it will cause a bottleneck. And bottleneck is latency, bottleneck is jitter. And if you have a bottleneck, you need to increase your resources. But there's no yes from nothing. You need to add equipment. You need to add sector. You need to add base station. This is how it works unless you can compromise with the service. Adjusting the ticks to avoid possible interference. Look, usually the base station is doing the adjustment of the tick's power, and there is another mechanism called ATCP. We are going to discuss those mechanisms tomorrow, but there is the automatic tick's power control. You can reduce the level of the tick's power in order to achieve better performance and not to interrupt your environment or your own base station. Usually in co-located interference, when you are reducing the tick's power, you are reducing the interference with the environment. If a lower tick's level would be sufficient to hold the remote link, it will definitely be sufficient for a closer links. To avoid possible interferences, we should reduce the ticks on both sides. The automatic tick's power control is doing it for you. There is dynamic and static the automatic tick's power control. We will discuss it tomorrow. We discussed about the difference between CIR and best effort. Best effort is equal share customer. Because it is equal share, then we try to avoid provide best effort to SLA customer. And this way or another, they will interfere. They will get worse performance, and your planning will impact the performance of the best effort. In order to guarantee the best effort performance, there is a mechanism, it's called the mirror. We need to adjust the mirror, the maximum information rate, in order to balance the traffic inside the system, to allow each one of our subscriber or best effort subscriber to get the service that he mentioned. So CIR customer need to have resources on the uplink and the downlink. We saw the impact of investment on the link on the CIR, and the idea that the more you are investing on the link, the more you are keeping your resources safe and available. Remember, the more you have resources, the less you have latency, and the more you can guarantee your SLA customer your IPTV, your video, your CCTV, your gamers services. Remember, there is a ratio between best effort and CIR to provide. The minimum resources for best effort customer is 1%. That is why the typical latency for best effort is one way is 43 milliseconds. For a CIR customer is between 6.5 to 6 millisecond latency. If you have a higher latency, then it's probably because a high subscription number more than you are planning, and your calculation is misleading, or it is a physical problem in your network that needs to be calculated. So increasing or decreasing the number of resources sets the required SLA services on the uplink and the downlink. At the end, you will see all the allocation, the resources that were taken from the base station. Total summary of the sector resources allocation. Exactly which resources are taken to which subscriber. You can see it, and you can see how many resources are left and how many subscribers are taking the resources and what is the utilization again of the network. Again, when you are deploying the link, you're deploying the network, you can get statistical reports from the WIN manage. Remember the NMS, RADWIN NMS, which can provide you reports on utilization of the network. So you can see how much your traffic is taken per day, per hour, per week. And then you can adjust the subscription number that we always talk about it, how to properly configure a system. A profile of the link, we saw that we can look at the profile of the link, and the auto connect is taken into consideration. This is the Fresnel zone, and about lower than 60%, it is near line of sight. Above 60% clearness is line of sight. Remember that RADWIN product can cope with near line of sight and non line of sight. I did myself in many countries, even in Africa and Kenya, non-line of solution, non-line of sight with the base station with the jet in 400 meters. It works perfect. The idea is to find the reflection area or the reflection point where you can achieve the link by reflection. But we are definitely can cope with non-line of sight and but for short distances and definitely for near line of sight and vegetation. We are coming soon with a TV white space solution which can penetrate vegetation for long distance, and this product will be introduced to you very soon in this year in Q3. And of course, when it is reproduced and released to the market, the planning will be updated as well for the TV white space channel. And this is different planning and of course different frequency in accordance. You can change the site position by unlock or lock the site. It can be moved, but remember when it adjusts, all the calculation will be done again. Let me show you. I just press here on the post unlock, and when I drag it, you can see it start to calculate again all the this RSS, the profile, the CAR, all the calculation that we did, the interference between base stations, the interference between collocated channels, the automatic ticks, power control, everything is started to do it again. Then the throughput will be changed according to different topological and geographical position. It will recalculate everything. And you can see, what was green became red, what red became green. It's a trade-off of what we are doing, and the R planner is doing it for you. And at the end, we can do different. For example, if this became red, let's see why it became red. And now I will ask you why we have a problem. Probably it's because of the topological area, because we changed topological. Let's look at this. Topological, let's see this. Properties. Oh, this one is not topological, it's availability. Why? We have 7.7 kilometers. We are working with integrated antenna, but the availability dropped to 99.8. Let's look at it. If I'm increasing the, let's put 50 megabits per second alpha, and the availability became 99.9. Availability dropped suddenly to 99.8 when the benchmark is 99.9, and so on. Auto connect, we saw the auto connect where the algorithm is doing the decision for you. And this is described how to do the auto connect, how to point the group of subscriber and base station. Once you point everything, you press on the button on the left to do the auto connect, and the algorithm starts to work and decide which subscriber is connected to which base station according to the coverage that you are planning. And actually, you can do it for thousands of subscribers. Let's look at it again. I just pointed area. Let's add the base station here. Let's put it in 45 meters. Look at the coverage. Let's put it a pop-up coverage. And we have a coverage. Now let's delete the links that I did before. And now I will do the coverage, press on the button of the auto connect, and there is a miracle where the machine working for us. And like the WinTouch. The WinTouch is better than any installer, believe me. And the RPlanner is better than any algorithm that we have in our mind. Although a human did it, but still, I hope that they are clever guys. But still, it's working very well. I didn't find any issue with this tool. The decision are most of the time, or 90% are better than non-experienced guy is doing the planning. Wow! Now look what happened. One subscriber went to one base station and the other to the other base station because of the distance probably. And let's look at this one. It's red. Let's see why it's red. Properties. And it's red because of lack of resources. I will put 10 with 10% and 10%. And I have 4 and 4, almost 7 megabits per second. Like I did the threshold 2 and 2, so, but still, now it's green. We have the throughput and we have two links. One is closer to the base station and the other is closer to the other base station. So this will make a good decision. Yeah, one subscriber to this base station, the other to the other station. It's a good compromise actually. Okay, point-to-point link is more easier because there are no resources. You need not to calculate any resources. You just need to do the throughput to decide which distance you need, which throughput, and which antenna gain you need to achieve in a distance. And again, the same benchmark: fade margin, RSS level, climate factor, TX power. And the decision, the most important is the throughput and the antenna gain that you are using. Now, Again, like we did yesterday, if there is an obstacle with topological area, you can bypass it with point-to-point and not point-to-multipoint. Star topology, D plus, C plus. Remember, this is a very important rule that I need you to remember. In a star topology, D plus, C plus, HBS will be deployed at the middle, since only HBS supports synchronization over Ethernet. This is a very important that some of you need forget, and I need to emphasize this again. In a star topology, when I put one central, let's look at, I will add entity, I will call it PTP, and now I will add a point-to-point link. Let's put the alpha point-to-point, let's fix the frequency, let's fix the channel bandwidth, the profile, let's put it 35 meters. And we have a link. Remember, at the middle, always, the base station. The HBS will be here, the HBS will be here, the HBS for this link will be here. And this point will be a synchronization. I will do a synchronization at the middle. Always at the middle. The base station, the master will be at the middle. Now, if I open again the HSS, you'll be able to see that, let's make a zoom. There is one master, and all the other are clients. The remote side, the subscriber side are independent because they are inherent the clock from the master, from the base station. So what happened in this tower? There is one master clock, which is the base station here. There is client, which is the base station here, and subscriber here, and subscriber here. Any subscriber will inherit the clock from the base station. But the master will synchronize all the clients under the same tower. That is why it's important that the base station will be connected in the central, where we can synchronize it over Ethernet. I hope it is clear, and this is a very important thing that we need to remember. There is one master, the other are clients, and all the base stations need to be connected in one central position so they can get the clock from the master. So creating a link, again, it's similar to point-to-point, point-to-multipoint, but now it is one link. We can go over the properties, and again, look at the availability, look at the phase margin, look at the RSS level. And again, we will need to decide which antenna gain in order to maintain the benchmark that I gave you. And this is always relevant for point-to-point and point-to-multipoint. Again, if the link is above lakes or above water, I need that the fade margin will be above 20 dB. The RSS, again, and you need to check the channel bandwidth, whether you can afford yourself to work in a wide channel bandwidth. Synchronization is very important, and we need to decide which synchronization method we are using over Ethernet when there is a master clock. If it is a mixed configuration, then a GPS needs to be used, and this is a link. So actually, we did a point-to-point, a point-to-multipoint. I discussed about the conditions and the differences between point-to-point and point-to-multipoint. Point-to-multipoint is more complicated because you need to allocate resources for CLA, SLA customer and CIR customers. We need to consider those resources, take it into consideration, and when we are doing the planning, the design of the sector, when there is a subscription number that we need to take into consideration, we need carefully to assign the CIR to point-to-point, point-to-multipoint customers. And we discussed about two methods of oversubscription. One, when you are utilize all the sector. Second, when you leave little percentage for bursting, where you can allow your customer to increase the traffic according to the needs based on free resources. Again, the R planner is based on the link budget calculator, the benchmark that you need to remember, and at the end, good planning, efficient planning can guarantee a good performance. It starts and ends with a planning. Tomorrow we will continue with the special tools that we can evaluate the quality of the design, the quality of the performance that we did, and at the end, we know how to configure a link, how to configure a point-to-point link and point-to-multipoint. Eldad, is there any special question or clarification that required?
No, not really. There are a few things but we can add them to tomorrow's webinar. They are not something that you covered today, just additional information required.
Okay, excellent. And tomorrow we will complete those clarifications and questions. Thank you for your time. Thank you for this session, and I will see you tomorrow.
Thank you all. Bye-bye.